Hi guys, how you all doing? Let's start today's LeetCode. Let's see what we have. Okay, maximum number of jumps to reach the last index. Okay, you're given a 0 index array nums of n integers and an integer target. Okay, you are initially positioned at 0. In one step you can jump from index I to index j such that I and j is less than n and greater than I. Okay, and so what does this say? Nums j minus I should be greater than negative of target, should be greater than equal to minus target. So 1 second. So let's say, okay, let me use my notebook. Where is my okay, okay, so let's see what we have is we are given an array nums. So let me take this example. I'm given an array nums. So example is example 1. I'm given an array of 1, 3, 6, 4, 1 and 2, and target is, you're given of n integers and a target integer n. You're initially positioned at 0th index, right? And in one step we can jump from I to j such that j is greater than I, so that j is greater than I and less than n. Okay, that condition is fine. And whatever nums j minus nums I should be greater than equal to minus target and less than equal to target. If there is no way to reach index, is given and an integer target. So to go from maximum number of, okay, return. So maximum number of steps you can make to reach index n minus 1. Okay, so maximum, so we have to reach n minus 1, but the jump should be valid with target. Okay, so for taking 0, okay, so initially, for example, perform the 0 index to index 1 as what? 3 minus 1 equals to 2, and from 1 to index, if I do 6 minus 3 nums bracket j, that j minus j nums bracket j is what? If I take 6 minus 3, which is equal to 3 is, doesn't satisfy, it's not in range minus target to target, right? Okay, that is fine. So we move on to 4. So as long as our difference between the two, so let's see, so one condition is absolute difference between nums bracket j, right, and nums bracket I should be less than equal to target. That's the main thing, right? If it's negative, and since we don't know if the target is positive or negative, it should also be equal to absolute of target. So how do we check? So we check the number of jumps, and we're not allowed to go back. So let's say if I go from 0 to 1, right, then I go from 1 to 3, What if I go from 3 to 2? So that is 6 minus 4, which is equal to 2, which should be correct. But then later on, I can't do 6 minus 1 and 6 minus 2. Yeah, that's thanks. So first is do I arrange it? What if I sort the things? What if I sort? Sorting won't work because I have to reach. Let's see. Sorting. What happens if I sort? If I sort 1 1 3 2 2 3 6 2 3 4 6. So let's look at another example. So we have target 3. So if I go from index 0 to index 1, index 1 to index 2, index 2 to 3, 3 to 4, 4 to 5. There is return your initially position. You can jump from. So if I go from 1 to 4. See, when I reach index 3, I am at here, right? Why can't I go back to 1? That adds another step. Then I go back, next step. Then from here, I can again go back to this step. I can add steps now, right? Use dynamic programming approach, okay? Where define a dynamic programming DP of size n, where each represents maximum number of steps from. Okay, for each thread overall. Okay, so they gave us to use dynamic programming approach. Okay, maximum number of jumps to reach the last index. Your initially position index 0 in one step. So what they've told us is we can use dynamic programming and define of size n, where each represent the max number of jumps from index 0 to I. So dynamic programming of I equals to max jumps from 0 to I. So dynamic programming of 0 is from 0 to 0, and for each j iteratable all yes, this is what I was. Oh, j must be greater than I, so we can't go backwards. And j must be greater than I, so can't go backwards. Okay, so one of the answers, my doubt is cleared, so we can't go backwards because of this condition. Now let's create an integer. Let me integer n equals to nums dot length, right? And then integer array dp new integer array of size n. size where dpi represents the number of jumps for each index in target. dp of I equals to, let me have teacher number of jumps equals to, okay, let's see. Let's do for integer I equals to 0, I must be less than n and I plus plus. What are we doing? We have to create dp of integer number of jumps equals to 0 at each so what is how from 0 to at each x and origin from 0 to index I. Then for j equals to 0, j must be less than equal to I, right? And j plus plus, what do we do? Number of jumps is j equals to 0, j equals to I, and j equals to I plus 1. So if I is 0, and j must be j equals to 0 and j must be greater than equal number of jumps from 0 to I. I equals I must be less than n, and we start j, and j must be 0 and j must be less than equal to I, right? And then we check if I is 2, again j must be less than equal to I, and we must not start on top of each other, right? J must be, if j is greater than I, then we check if j is greater than I, and integer value equals to nums bracket j minus nums bracket I, and if and what and value value is good. Value should be either, should be in if j is greater than I and value is less than greater than equal to minus of target, or value is less than equal to target, or value is greater than equal to target, right? So or operator will true or false will be true. Value is less than equal to 2, value is less than equal to target and greater than equal to negative target, and we do bit of jumps plus plus, then we add tp bracket I to number of jumps. J is greater than I and value is greater than. Okay. If J is greater than equal to, then check if. So if value else continue, right? So we create the number of jumps for each J iterate over. Okay, so what do we do next is what they've asked us is for each J we give the number of lengths greater than 2 or no? Yeah, number of lengths greater than 2. So what do we do? For I equals to 0, I must be less than n, I plus plus. J equals to 1, J must be less than I n minus 1. Right, so I is here. So for teacher I 1 minus 1 and J must be less than n. 1 second, and here 2. Number of jumps from to n minus. I gotta use the washroom. I'll be right back. Let me pause the recording. Okay, I'm back. Okay, so where were we? So we created. So what DP will do is, so what we have here is, so we go from 0, from this up till 1, and then we get all at each index how many steps we need to reach from here to here, right? So from I equals to 0, from 0 to, and then J is 0, J must be less than equal to I. From 0 to 0, number of steps is 1. For J equals to 1, right, from integer I 0, J is at 1. So when J is this one, this loop. So when I is 1, and J is also 1, from 0 to J, how many steps? So 3. No, I think I have it in the reverse order. So what we're doing is, let me draw this. So if I have 1, 3, 6, 4, 1, let me. So if I have 1, 3, 6, and 4 for now, our I is at 0, right? I starts here, and J starts here, and J must be less than equal to I. So the first loop when I is 0 or J is 1, but J is not less than equal to I, so this won't work. So when our I is 1 and J is 1, so number of steps from here. So condition is that j must be greater than I, right? J must be greater than I, but instead of each I. Okay, so dp of I is number of steps. dp bracket I is max jumps from 0 to I. So from 0 to 1 number of jumps, 0 to here number of jumps possible, right? So I don't think I should add this here. And then here j must be, so let me think of outer loop as j and inner loop. So for I equals to 0, so that is at each element, I want to check. So this is the outer loop, right? For each element I 0, 1, 2, 3, right? Number of, so let me go from I equals to this to I must be less than n. So up till here, n minus I starts here, and we go up till n, this product. So for j equals to 0, and j must be less than equal to, 1 second, pause. Okay, sorry, I was talking to my friend. Okay, let's get back. Okay, so where were we? Okay, so I go from 0, so let me rename it. Let me put this as j equals to 1, j must be less than n, and j plus plus for int I equals to 0, I must be less than equal to j and I plus plus. So as long as I is less than j, I is less than equals to, no, right, so I is less than j, so I is less than j. So if our j is 1, we start from 0 to 1, how many steps it takes us, we check if, so we don't need this loop anymore, right? We do if value, we do equals to nums of j minus, if the value is less than equal to target, right, our value is greater than equal to target number of jumps plus plus, right? And then what do? We add the jumps, and then dp bracket j equals to number of number of jumps, right? So initialize dp bracket 0 equals to 0, and then for int I must be less than, okay, so we got this correct, I think. And then what we have to iterate for each, int I equals to j must be less than n, and j plus plus, right? So we loop through each number, and we have j. So what we do is, and then if I is less than j, we do dp of j is dp of j equals to max of whatever is at initially, comma dp of I plus 1 okay, so we have the dp array where each element is number of jumps, number of valid jumps from 0 to that position. Next, okay, let's see if what am I doing wrong here? Let's just use cloud chat as me. This is what I have done so far. Correct mine and explain. Oh, right. So if other conditional. Okay, so initially what we had to do was, where is it? Oh, no. Okay, so when we create dp arrays dot fill dp with -1, make all reachable, then we initialize 0, then for j equals to 1, j must be for integer. Okay, I don't need the number of jumps here. Skip if I is okay. dp of I is itself unreachable. Why do we do a skip here? What we are doing is, if dp of I is equal to -1, continue. Teacher value is equal to nums j if fr, if the value is this and if value is if the value is less than equal to target and value is then dp bracket j is to math dot max of dp of j comma dp of I plus 1, right? And then p of n minus 1. So what happens here is I is 0, difference is 3. Okay, let's see. Okay, that was fine, but I needed to use I did use hence. Actually guide myself to DP approach, but initially I thought of using BFS. How do we determine pattern in these kinda questions? BFS is because looks like all right. I guess I'll see you next time.